Okay, for this lesson, we're going to learn how to find or write the equation of a circle in standard form. So this is one of those unique lessons where we get to put geometry and algebra together. So we're going to use the geometry that we know of circles, but we're going to look and see what does that look like on a graph using variables from an algebra perspective. So if I start with any point randomly on a graph, um, and I try to find the distance from one point to another point, what we've done there is we've used the Pythagorean theorem to say that for this triangle, if the Pythagorean theorem is true, which it is because would be a right triangle, we know that x squared plus y squared equals r squared. And I can draw a circle from this point here, we'll call this the center of the circle, out to that point. And x squared plus y squared equals r squared defines all the points that would work. For example, if I move my triangle down here, so x is still where it is, this is still a length of y, it's just down instead of up, and I drag this point down here. This point is also on the circle, but this point, to get to this point, we still use the equation x squared plus y squared equals r squared. If I go to the left with my x value, and I go down with my y value, I can still create a triangle. This is still the radius of the circle, so it's still x squared plus y squared equals r squared. And that equation, and let's say we have this center, this is not, let's see here. So we have this x squared plus y squared equals r squared. That's true for all these different points. I can put another one up here, drag this green around one more time. X squared plus y squared equals r squared. Okay, so that's true for all these triangles. I could even do that if I had a point, instead of having a point at a triangle, I just had a point straight across. In this case, since my x is my straight across number, my x would be the same as my r, and my y would be 0. So in this case, it would just say x squared plus 0 equals r squared. So it works to have a point here as well. And I could even change, let's say I want the green one to be there. If I change this x to any length, as long as I change my y to match it, I can still get that same r value. So it doesn't matter, there's different values of x and different values of y. Can't move the y right now. That would still satisfy this equation, x squared plus y squared equals r squared. For our purposes, x squared plus y squared equals r squared is going to be the equation of a circle when the center of the circle is at 0, 0. So if I go to Desmos and I type in x squared plus y squared equals 1, I have a circle with a radius of 1. If I type in x squared plus y squared equals 16, I'll have a radius of 4. If I change the 16 to 9, I'll have a radius of 3, so from the center to 3. If I change the radius to 25, I'll have these points that are all 5 units away. If I change it to 81, then I'll have a radius of 9. So this value is always the squared value of the radius. So x squared plus y squared equals 1. And again, that's always with the center 0, 0. If I want to move this away from the center, have to put in some parentheses. And I can move it away from the center by adding numbers to the problem. So let's keep it with a radius of 1. Let's make it we'll keep it a radius of 1. So if I put a -1 next to the x, it shifted my circle to the right. I'm going to turn off my red circle. So -1 shifted to the right 1. -4, move my circle to the right 4. If I do +1, it moves it to the left 1. If I do +4, it moves it to the left 4. For the y value, if I do -1, it goes up 1. If I do -2, it moved up 2. If I did -4, the center's now up 4. If I wanted to go down, I have to do the opposite. So instead of going, if I wanted to go down 1, I have to type in +1. If I wanted to go down 3, I type in +3. If I wanted to go right 4 and down 2, right 4 is -4, down 2 is +2. So the standard equation of a circle with a center at h comma k and a radius of r is this equation. You could say that x minus h moves to the right h, x plus h moves to the left h. You could also note that y minus k moves up k, y plus k moves down k. So let's do a couple practice problems. Okay, write the standard equation of a circle with a given center and radius and graph it. Okay, so my center is at 3, 2 with a radius of 4. So that means I've gone to the right 3 and I've gone up 2 and a radius of 4. So here's my equation. Okay, so going to the right 3, I'm going to do x minus 3 squared. Going up 2, I'm going to do y minus 2 squared. My radius is 4, so radius squared is 16. So right 3 up 2, so that's this point here. Make my center a little bit larger. And then I have a radius of 4, so I'm going to go 4 to the right, 3, 4 puts me at 7, 4 to the left, 1, 2, 3, 4, 4 up, 1, 2, 3, 4, 4 down, 1, 2, 3, 4, and then I'm going to draw a circle. So I have a circle tool that makes it much easier than just trying to draw it freehand. And that's my graph to go with my equation. Let's try another one. Center at 0, 1 and a radius of 3. So center at 0, 1, a radius of 3. So 3 in any direction. So, and 1, 2, 3, I missed on that one. Okay, so you draw points in all 4 sides, and then draw your circle the best you can. And then for our equation, we're going to have the x minus 0, the y minus 1, and a radius of 3. So x minus 0 is just x squared. The y minus 1 to go with that 1 that's there. Radius is 3. Radius squared is 9. look at a couple examples of going backwards if I have the equation of the circle. So first we identify where the center is. The center is right here at 3, 2, and a radius length looks like 5. So center at 3, 2, radius of 5. When I go to write my equation then, I'm going to say x minus 3 squared plus y minus 2 squared equals 25. X minus 3 squared plus y minus 2 squared equals 25. Same thing, different problem. I have a center at 0, 1. I have a radius that equals 9. So center at 0, 1, radius equals 9. So you can write x minus 0 parentheses squared, or you can just write x squared. Then we would say y minus 1 parentheses squared. That equals 9 squared, which is 81. And last, just find the center and the radius given the equation. So for number 1, there's no other numbers. We know that the center is at 0, 0. And the r value, this 81, is equal to r squared. So r has to be 9. For number 2, the x minus 2 tells me it went right 2. The y plus 5 tells me that it goes down 5. So I'm doing the opposite of what it looks like. The minus 2 is actually right 2. Plus 5 is really a down 5. So that's at 2, negative 5. And then my r squared is 24. So r is going to be the square root of 24, which we could also say is 2 square root 6. So those are some examples and some basics of how to work with the equation of a circle. If you have a question about why the values are opposites of what they are in the equation, like x minus 2 is right 2 and y plus 5 is down 5, you can join your teacher for Google Meet this week and ask them, and we'd be happy to go through that with you. All right, thanks.